can get our slideshow set up from current slide, and we'll move on from there as soon as we can. Okay, a few announcements. A couple of these good informational things. The counseling service, and they just sent this yesterday afternoon, so I didn't have time to give you much warning on it, but here I got this. The counseling service is presenting drug use and its legal repercussions. Our presenter will be our Chief of Police at Lawson. He's usually on the Birmingham campus, but he'll be out here today to do this, Chief Blanton. The student seminar is today, the 30th, my brother's birthday, okay? The faculty staff dining room in Building A from 11:30 until 12:30. 1 hour presentation. If you can get there, if you need to, run and grab your lunch at the cafeteria right next door. Here's the faculty staff dining room right here. If you leave out of this, you won't be leaving from here. How to get there from here, go down this long hallway here to the second set of stairs, go down those stairs, pass the flight, and then you wander around a little bit of wrinkle in here, then the faculty staff dining hall just next to the cafeteria. So that's where you'll be speaking today. So that's 11:30 to 12:30. Good deal, thank you. It must be the end of the month, huh? Here comes, here comes the papers. Good to see. All right. All right. So for those who just came in, drug abuse and its legal repercussions presented by Chief Blanton, our Chief of Police here at Lawson, from 11:30 to 12:30 today, faculty staff dining room. Okay. If you want more information, Dr. Renee Herndon has that. I've got phone numbers and email. Miss Kimberly Moore, I think she's on this campus too, I think, yes. And if you're going to be on the Birmingham campus later today, this will be at the Leon Kennedy Center, the Space Center. How is he going to do this? Oh yeah, that gives him time. 30 minutes to get back there, and it's 1 to 2 o'clock on the Birmingham campus. Leon Kennedy Center, the Space Center, room 207 upstairs. There, contact Miss Janine Jones or Miss Leslie Harper. I have phone numbers and emails for both of them. So please try to go. It's good to know. You may not think you have anything to do with it, but you know, it's going to creep up. And somewhere in your lifetime, if it has already happened, some family member, some neighbor, there will be an issue. I almost guarantee, unfortunately, that's kind of a safe bet these days. Now, they also come out with a cafeteria menu. They came out with this sort of late yesterday, so couldn't announce it any earlier. But I'm going to just give Bessemer, if I can find it here. Here we go. Today, they're having TPA. They haven't announced what it's going to be. Tomorrow, though, is taco salad, and I'll give you the rest of it as we get closer. Okay? If you need to know Birmingham campus, both the noon and the evening menu, I've got it here. You're welcome to look at it. By the way, check your email. It went to you as well. Let's see. Well, no, that doesn't show up, but I'm sure it did. And then, again, I've said it before. I'll say it repeatedly. If you're at all interested in participating in the math team, contact Miss Nyla Gerasi or see me. And if you want some practice rounds on this campus, I can do it. I've got a lot of free time this first mini term, so let me know. But second mini term, I'll still have a fair amount of free time, so we'll be able to schedule those practices. She's going to schedule them, I think, Monday, Wednesday afternoon at 3 is what she said. Maybe not every Monday or Wednesday, but some. It's a great way to get a heads up, a leg up on your next math courses, okay? And it's a lot of fun. Okay, the final announcement, unfortunately, is one that does impact this class directly. I think I told you earlier in the term that I have a mild form of leukemia, and I take treatment for it. Had been doing about once a month. Okay, get your name, please. Huh? Holman. Thomas. Can't hear it. Thomas. Thomas. Okay, got it. Yeah. Okay. Got it. Okay. Well, I saw my doctor, the hematologist, on that Tuesday, remember we had rescheduled a class, but then it wound up being a weather day anyway. It was the 16th, I believe it was. And the blood work came back, and actually our counts went up from before the previous treatment to the last treatment. I mean, between the treatments, so the treatments aren't doing nearly as good as they did to begin with. They're doing something. So anyway, he wanted to try a new drug, okay? And he had one in mind, but it hadn't been approved for recurrent cases like mine. I've had this since 91, okay? Most of you weren't born then, probably, okay? So it's not a real serious thing, but the blood counts go up, the white counts go up, so they try to keep them in check. They treat the disease. Hopefully it'll go cure it one day, but right now it's just treating it. And so he wants to try this new one. They did get approval for it, and I got a message on the voicemail yesterday when I got home. My wife was telling me, and then I heard it. They want to start treatment day after tomorrow, Thursday. Okay. And it'll be a 10% dosage that day, but I have to be at the Kirkland Clinic at 6:30 for blood work. 7 o'clock they start the treatment, and it goes all day long because monoclonal antibodies are developed in animals, probably rats, okay, or something, and then they try to clean out all the trappings of that, just get the antibody. There's always little residue, sort of, that's not the right way to say it, that you can react to, and so they do it very slowly to make sure you don't have something like an anaphylactic reaction. So it'll be all-day affair. So Thursday we will not be having class, okay? When do you want to try to make that up? And I'll have the 90% treatment on Friday, so it won't be Friday. It'll be all-day affair that day too. So best shot would be next week. Is Monday or Wednesday or Tuesday or Thursday better for anybody? Tuesday, okay. I have a class right after this at 9:30. I'm free at 11. I'm free the rest of the day, okay? So with 11 o'clock, 12:30, 2 o'clock, 3:30, what would be the best time for anybody? Say again?
I know I have a class
at 2. That won't work, okay? Say again? Another class at 2. Okay. So, what's that? We will have class Tuesday, yeah. And we'll have regular class and then makeup class. Yes, double your, for no extra charge. Okay. So, want to do it Tuesday? Yes.
What's our first quiz?
When we finish 1.6.
What about test?
Say again? Test when we finish 1.9. Okay? I mean, yeah. Okay. So, 11 o'clock Tuesday, 12:30 Tuesday. Can't go as late as 2 because there's classes at 2. And I doubt if you want to drive back there. Huh? 12:30 Tuesday. We'll have the makeup class. Now, if you can't be here, that's okay. I'll record everything like I always do, but the more of you that are here, then the more you get to ask questions and interact with me. If nobody's here, I get to go as fast as I want to. So come here and slow me down. Okay. Okay. That's the carrot. Okay. So we'll make up the class Tuesday, 12:30 we said, right? Okay. Good deal. Okay. Any questions on anything we've covered so far? Okay. Now, in the last class, we did this exercise looking at these. And they're going back, and we talked about this. Example 7C had the volume of a sphere, which doesn't put any explicit limit on the domain, but there is an implied limit, an implicit limit, in that you can't have a radius less than, you can't have a radius of 0 or less. It has to be a positive radius. So that's what they're talking about in this slide. We ran out of time. Okay, so in example 7C, Note that the domain of the function may be implied by the physical context. Does it make sense? Okay? If it doesn't make sense, imply the domain that does make sense. Here was the one we did. B is equal to 4/3 pi r cubed. You would have no reason to restrict r if this was just y is equal to 4/3 pi x cubed. If it wasn't the volume of a sphere, and that's what it was, all real numbers would be your domain. But this represents the volume of a sphere. The physical context implies the sphere cannot have either a 0 or a negative radius. So therefore, you restrict the radius to positive values. All r is greater than 0. And that makes the range also all volumes greater than 0. You can't have a negative volume or 0 volume either, okay? You wouldn't have anything if you had a 0 volume. All right, I think we beat that one to death, but that's where we left off last time. So let's move on to applications. First of these is you work. Any questions before we go? Okay? You work in the market and, oh, time out. This happened in another class and I forgot that I hadn't said this earlier. So let me say it now while I'm thinking of it. After class yesterday afternoon, a student said, where do I get tutoring? I must have gone a bit too fast or furious in the class. I said, oh, okay, I should have said that early on. Most of you have been around, you probably know, but in case you don't, we have 2 great tutoring sources on this campus and another 3 on the Birmingham campus. Okay? Can you get your name, please? Brianna, I thought so. All right. On this campus, if you go down this long hallway here, same place I had you going before, to that second stairwell, right there, right across from that, is the tutorial lab. It's SSS tutorial lab, and that's room 202, I believe it is. Say again? No, I could do tutoring in my office anytime during my office hours, but no, this is either professional tutor or student tutor, okay? Generally students, okay? So go see Miss Hollins there, and she will arrange and do that. Now, if you go down those stairs to the first floor, not to the first level, but down all the way to the bottom, come out of that stairwell and hook back around to the immediate right, that would be the Space Center on this campus. And they have 3 tutoring there too. Good tutors, both places. On the Birmingham campus, you have SSS tutoring in the C building. I can't remember that room number, C104 maybe, or something like that. There's a SSS tutoring lab there. Mr. Jeff Harris is most of the time in there, but I think he has some student tutors as well. And then they have a Space Center in the Leon Kennedy Center up in room 207, wasn't it? On the, 207 in the Leon Kennedy Center. And they also have the STEM lab, which is B118, I believe it is. Now, I don't know what their tutoring schedule is, but usually they have tutors there as well. Okay? So lots of tutoring opportunities, both campus, absolutely free. Okay. I guess your question about the quizzes and tests probably need to remember. Okay, let's get back to the problem. Example 8. This, by the way, is on the top of page 41 in your text. You work in the marketing department of a soft drink company and are experimenting with a new can for iced tea that is slightly narrower and taller than the standard can. For your experimental can, here's what you're given. The ratio of the height to the radius is 4. Okay? Now, when I read a problem like this, as soon as I hit some statement like that, I want to write it down. This is in English. We need to translate that to mathematics. Okay? Okay, now, you want to use a symbol to represent height. A variable. H. Oh, what a clever idea. Okay? So let's use H. The ratio of the height, H. Let me get my pen. Okay. Height is H. Okay? And let's see, radius. What might we call the radius? R. Oh, good idea. Okay? So the radius is R. So how do we express the ratio of the height to the radius? What does that mean? What is a ratio? Surely. Say again?
It's like something against something.
Something what?
Like against it. Like you're comparing the two.
Yes, comparison of two numbers. How do you compare it? In what sense? You got four basic operations. Adding, subtracting, multiplying, dividing. What sense are you comparing a ratio? Dividing. Excellent. Okay? So the ratio of height to radius would be h over r. Is. Okay? How do you translate is? Equal sign. And 4 is 4. There we have it written algebraically. Now they wrote it here, but I want you to think through it. So that's why I didn't point that out. Okay. And again, they showed the can. Thank you for drawing it for me. Height, radius. And the ratio of the height to the radius is 4. Okay. Now it says, write the volume of the can as a function of the radius. So volume as a function of radius. Does anyone remember what the volume, and this, by the way, this can is going to go straight up, okay? It's not going to be a leaning can or a wobbly can. It's going to just go straight up. And we're going to make an assumption here, since it said the radius. Guess what the top and bottom is? What shape? A circle, okay? Circles have radii, okay? So it's a circle of radius r and a height h. Does anyone know what the volume of a right circular cylinder is? Let me give you, anytime you have a regular shape, usually the volume is the area of the base times the height. So what's the base? Circle. What's the area of a circle? Oh my. Pi r squared. And I always thought they were round, but no, pi r squared. So the area of the base, pi r squared, and then the height is h. So therefore, the volume of this can is pi. I was doing the last one, okay. Pi r squared h. Well, there we have the volume of the can as a function of radius and height, but we don't want the height in there. We want it only in terms of radius. So, we need to get that h out of there. How can we do that? Tell me a ratio. Huh? How? Okay? Okay. Go back and look here. Solve this thing for r, for h. And then you have an expression of r, plug it in, plug it in. Okay? First thing we do is solve that for h. How do we get that solved for h? Multiply both sides by r. Absolutely right. And that gives you h is equal to 4r. So now we just plug in, instead of h, we get it in terms of r. So this will be volume is equal to, let's bring the 4 out front, 4 pi. We had r squared multiplied by another r. That will give us r cubed. There we have it. Volume of the can as a function of the radius. Only, not with the height in there. We know that only because they gave us the ratio of the height to the radius. Okay? Does that make sense? Next, they say write the volume of the can as a function of the height only, h only, not the radius. What are we going to do now? Help me, help me. We go back to this formula, which is our general formula of the volume of the can. But now we want to get the r out of there and put h in its place. So So in this case, go back to what we know. That. Let's solve that for R. What would that be in terms of R? And R alone. I'm sorry, in terms of R. In other words, solve this for R. What does that give you? What do you do? How do you do that? Divide by 4. Isolate the R. Okay, now you get R is equal to H over 4. Ha! So now in that first formula, V is equal to pi R squared H, we put V is equal to pi times H over 4, that's what R is, squared times H. All right. Someone open the floodgate, and here they come. Okay. Monica, got it. No, you're in here. There you are. You were near the top and?
Mayfield.
Huh?
Mayfield.
Mayfield, got it. Okay, my hearing's bad. Okay, and? Fowler. Oh, yeah, I should know you. Okay. All right. Anyone else come in since I called roll? Okay, and since some of you did come in since I called roll, let me repeat this again. I had a phone call yesterday when I got home from work, a message saying my hematologist wanted to start a new drug Thursday. Okay, so I've got treatment all day Thursday and Friday. Okay, so I will not be here Thursday. We already talked as a class when we can make up that class, and we decided let's shoot for next Tuesday at 12:30, right? That's what we decided, right? Next Tuesday at 12:30. If you can't be here, I'll be recording it all, so listen up for that. We'll have class at 8 on Tuesday, and then we'll have the makeup class at 12:30, okay? The more of you here, the more you can interact and answer. If you can't be here, you can watch it on YouTube, okay? If nobody's here, I get to talk as fast as I want to, okay? So somebody come, okay? Be as many as possible so you can ask questions and we'll interact. So we're doing the B part of this problem. It's on page 41, top of the page. We're writing the volume of the can that we wrote is V is equal to pi R squared H. We first did it as a function of radius only. Now we're writing as a function of height. So we got the radius in terms of height, which R is equal to H over 4, because they told us the ratio of the height to the radius is 4. We had that formula, and we went from there. Now we just have to clean it up, and what does this give us? Let's get the fraction part. What is 4 squared? Not that hard. 16. So that's in your denominator. Pi is a number 2, so let's put pi over 16. That's the numerical part. You have H squared times H is H cubed. There is the volume as a function of height alone. Here's the volume as a function of radius alone, and we use what they gave us, that the ratio of the height to the radius was 4. We use this formula here. Now we multiply here by 4, and we divide, by R, here we divide it by 4, and that's how we got it. H is a function of R, and R is a function of H. We'll plug into our formula. Any questions? So you see, you need that one piece of information then to make your various changes. All right, any questions? By the way, there's a checkpoint, and every checkpoint has audio-video solution at larsonprecalculus.com. So if this has been a little fuzzy, be sure you do that as soon as you can. Chris is here, right? Okay. Good deal. All right. So here we have how they do it. First, the volume. I wish I hadn't written it this way. The volume of any right circular cylinder is pi r squared h. And by the way, I had you figure out what it was, but in case you don't remember those things or want to check yourself, a lot of times the book will have, but not this one, did in the old edition. Here we go. Back inside cover, volume of a right circular cylinder, V is equal to pi r squared h. So that's where they got that. You didn't have to know it, but it's usually a good idea to figure it out if you can. You were already here, so okay. All right, so there's our formula for any right circular cylinder, pi r squared h, the volume, and we solved the ratio for h to get it in terms of r, so you can plug in what h is instead of in terms of r, so you get this strictly in terms of r. Now this is a function of r alone, and we can pull out the 4 pi in front and have r cubed at the end, just like we did. Any questions? Okay. Doing it the other way, we want it as a function of h alone. I wish they hadn't written it this way because that's a function of r and h. But this time, we solve the ratio for r and plug that in terms of h, and you have the volume in terms of h. So pi is equal to h over 4, there's your r, from that ratio we knew, squared times h. And you square the denominator, put it under the pi, that would be pi 16ths. They wrote it on top, it doesn't matter, times h cubed. Which leads me to say, remember when we did it, I said pi over 16 times h cubed. They wrote pi h cubed over 16. Same answer, absolutely correct. If you're doing this on WebAssign, it's going to mark one of those wrong and one of them right. And both of them are right. That's one reason I don't really care too much for WebAssign. But WebAssign does have great tutorial help and lots of practice problems. It's all set up for you. If you bought a new book and had a code, got a code, then by all means use it. Okay, I just won't make any assignments over it because I don't want to be say, no, that's right. Even though they said it was wrong, it's right. You fight it out with, use the tutorials. They're very helpful. All right, now let's move to, they're skipping example 9. So let's go back and do example 9. Path of a baseball. A batter hits a baseball at a point 3 feet above the ground. Does that make sense? Okay, swinging the baseball. Where's the typical place you're going to hit it? About a yard off the ground. Now, if you swing way up here, you may miss it, or way down there, you probably going. That's a sweet spot right there. Yeah, that's about where a batter dreams of hitting the baseball, about 3 feet off the ground. Okay? And he, at a point 3 feet above the ground at a velocity of 100 feet. It makes it sound like either the ground's at a velocity or the point's at a velocity. It's he hits the baseball with a velocity of 100 feet per second. So that's going to be his initial velocity. And at an angle of 45 degrees. Okay? Now, when you have a problem like this, in the previous one, they drew the picture for you. If they haven't drawn the picture for you, you draw the picture. Here, I'm going to draw a really ugly picture of a batter holding a bat up here. He's going to try to hit a baseball here 3 feet above the ground. So I'm going to call it right now Y sub I, initial displacement of the baseball, is 3 feet. Okay? And when he hits the ball, swings the bat around here and hits the ball, then it's going to be takeoff from here with a velocity, initial velocity of 100 feet per second. He really swatted it. Or she, okay? And at an angle of 45 degrees. So this angle is 45 degrees. Okay? So there's your initial picture. Now, the next sentence here says, the path of the baseball is given by this function, f of x is equal to minus 0.0032. What a nice little number that is, okay? X squared plus x plus 3. Okay? What do all those mean? F of x is the height of the baseball. I can't write. Okay? That's the height of the baseball in feet. Okay? And x is the horizontal distance. So this is going to be your x this way. Horizontal distance from home plate. Okay? There's what your x is. Okay? Now, let's just see if this makes any sense to begin with. Right before he strikes the ball, what's the height of the ball? Okay, what's the displacement? Horizontal displacement. He hasn't hit it yet. Horizontal displacement is? Zero. It hasn't moved any. It's right where it was, okay? Horizontal displacement is 0. You put a 0 in here and a 0 in here. What's the height? 3 feet? Yeah, they told you that. Yes, this is set up well, okay? Okay. Now, you might wonder, where did they get this weird number like this? Okay? I can't tell you all of it, but I'll tell you part of it. The 32 comes from the fact that the acceleration due to gravity anywhere on the surface of the Earth in U.S. customary system, 32 feet per second squared. Okay? That's where the 32 came from. Why all those decimal places? Initial velocity was 100. Basically, you squared it and divided by it, so that's what moves the decimal 4 places here. You don't need to know that part, but it is making sense. Okay? So, this is how far the ball moves by acceleration. This is by initial velocity. I mean, how high it is, and that's how far it was to begin with, initial displacement. Okay. It's a real quick and dirty and not very accurate, but that's where all that sort of makes sense. Okay. Where f of x is the height of the baseball in feet, blah, blah, blah. Here's the question. Will the baseball clear a 10-foot fence located 300 feet from home plate? Now, my scale's going to be pretty lousy here, but here's a 10-foot fence, okay, maybe a little taller. The fence here is 10 feet, okay. Will it clear the fence if this is, now this is the part that's really the 300 feet. So that doesn't at all look like 300 feet, but that fence is 300 feet from home plate. All right. Now, will it clear that? Okay, what does 10 feet represent? Height. And what does 300 represent? Horizontal distance. So this is your x, that's your y, which is your f of x. So let's see if it works. Let's plug in 300 here and see if we clear the 10-foot fence or not. So what we're going to do is f of 300 feet. That's how far it went, 300 feet horizontally. And that would be negative 0.0032 times what? Second? No, the x stands for the horizontal. That's the 300. You wanted to square the easy one, didn't you? Okay, I got you. Okay, but you can't get away with that. Okay, I know CJ's in here somewhere. There you are. All right. Anyone else coming in since I called roll? So that's going to be the 300 feet. I'm going to leave off the units for now. Squared plus what? 300 plus 3. Don't forget your 3. Okay. That may be all. You need that 3. Okay, let's see. What are we going to do first here? Square root of 300. What does that become? 9. The 3 squared is 9, but then you double your number of zeros. You had 2, double them to 4. 90,000. But the good news is you got a decimal here, move it 4 places this way, move this one 4 places the other way, and you've wiped out, and it's just 9 times 32. So it makes the math a lot easier. You don't have to punch all those numbers in. So what does that give you? Negative 9 times 32, that would be 1828. Negative 288 plus 300 plus 3. What does that yield? Anybody? Not that hard. You can even use a calculator if you need to, but it's not that hard. 15! Cleared the 10-foot fence with room to spare. Yes. And not even Michael Jordan playing center field could have, and he used to, didn't he? Was he center field? Anyway, he was outfielder for the Birmingham Barons for a little while. He couldn't jump that high to get 15 feet. Nope, he would have missed it. Gone over his head. All right. So the baseball will clear the 10-foot fence. Okay, there's a checkpoint there. Please do the checkpoints. I would say as soon as you can get away with it. Okay? Now, guess what? There's another example application they didn't show, and we won't do maybe as much time on this one, but we will. I'll show you how to do this. Is that a stretch or a question? Just a stretch? I think so. Okay. All right. That was just a stretch. No question. Okay. All right. And that's on page 42, example 10. Alternative fuel stations. Okay? I'll hold this up in just a minute. The number S of fuel stations that sold E85, that's ethanol, gasoline, gasoline ethanol blend. It's rather strange they call it E85. 85% gasoline, 15% ethanol. Okay? In the United States, increased in a linear pattern from 2008 to 2011. Then increased in a different linear pattern from 2012 to 2015, as shown in the bar graph that I will show you if you don't have books. Now, a lot of you looks like you don't. Here is the bar graph. Now, this doesn't show up on Screencast-O-Matic because it's not being projected. I'm just using the light from the projector. So from 2008 to 2011, fairly much a linear increase. And then from 2012 to 2015, another linear increase, but it wasn't as sharp of an increase as you had before. Whoa, that was heavy. Okay. Now, here is they're using S for the number of stations. So S as a function of T, where T is measured in the years. Now, we're not going to use 2008, 2009, 2010. That's just such big numbers. We're just going to use the number of years since year 2000. So 2008 will be 8, 2009 will be 9, 2015 will be 15. Okay. So, where T represents the year, with T equal 8 corresponding to 2008. So here's your function. It's a piecewise defined function because you have different slopes there. For the first few years, 4 years it looks like, it's 260.8 T minus 439. And this is for any T between 8 less than or equal to T less than or equal to 11. Between 2008 and 2011. It's 151.2 T plus 714. And that's good only for 12 less than or equal to T less than or equal to 15. The next 4 years. Okay? Now, they come up with this kind of stuff through a process called least squares fitting. You don't need to know that, but that's where they get this type of thing. But here's the general information it gives you. It's not precise, it's not exact, it's just general. For the first 4 years there, 2008 to 2013, you added about 261 stations per year. That's what it's saying. Stations per year, per time. Because you multiply by time and you get stations. Now, this number makes almost no sense. It's just what it takes to fit that. Okay? If you go back to the graph here, okay, this is hard to hold, but on that graph there, this would, the slope down here, and you see there's all sorts of wiggly stuff down here, it would actually be a negative number at 2,000. You know that wasn't true, okay? You don't have a negative number of stations. But you're not worried about that. The domain here is what? 2008 to 11 and 2012 to 15. You're not at all concerned with what it was in the year 2000. That's outside your domain. So don't use this to predict anything there. It's only good within that domain. That part for that part, this part for this one for that part. Okay? And then the next 4 years, 2012 to 15, the still was increasing the number of stations, but now only at a rate about 151 per year you were adding. Now this time the y-intercept was a positive number. Again, that doesn't make any sense because you never were back at year 2000. That would have been the y-intercept. So you're not worried about that. It just made the curves fit. Okay? Now, what it says here to do, use this function to approximate the number of stations that sold E85 each year from 2008 to 2015. Oh boy, I want to take a lot of time and do that. I want you to pick a year, any year, between 2008 and 2015. Pick a year. 2010. Okay, where are we, Waldo? Which one would we use? The top or the second? The top, because that's 10 is between 8 and 11. So S of 10 in 2010 would be 260.8 times 10 minus 439. Okay, this is a pretty easy one to do. Thank you for choosing 10. This would be 2608. Just move the decimal one place to the left as you move that one place to the right, minus 439. And that would be approximately how much? That's a 9. That, I believe, is a 6. I think that's going to be a 1 and 2. That seem about right? Okay. Let's see. 2010. 2169. Yes, got it. Give me another year. 12. Okay, like it. What is S of 12? How are you going to estimate that one? Use the bottom because that counts to 12 down here. So that would be 151.2 times what? 12 plus 714. Now this will be a little harder to do. Someone got a calculator, punch it in so I don't have to do all that thinking, not this early in the morning. Say again? Okay. Anyone got the answer yet?
I got
528 what? 0.4. Let's just call it 528 because I don't see too many 0.4 stations out there. Okay. Oh, 2,000. Okay, that sounds better. Okay. I can't hear well. 2,528 stations. That looks like it makes sense. Because we knew it was still going up, but just not as fast as it was a while ago. And let's see what the book got. 2,528. Yes. They did it for all 8 years. You can do that if you want to. This is all we're going to take class time to do. You see how we did it? Piecewise defined function. When you know what year you're looking for, figure out which piece of that you're going to use. So the top one, 10, is between 8 and 11, so you use the top one. 12 is between 12 and 15. It is 12, so you use the bottom. And plug in the year that matches. Okay? That one came out a whole number, and it's still an approximate number. The second one came out a decimal number. We're just going to assume it's a whole number of stations. You know, you don't have 0.4 stations. All right, and this actually came from Real Data, Alternative Fuel Data Center. Okay, came out with that process. Any questions? How you use functions? All right, now we're going to talk about difference quotients. Y'all have run into difference quotients before? Yay or nay? Yes or no? You remember doing difference quotients? Let me tell you. Sure you have. They just didn't call them difference quotients. Okay, what do we mean? Difference. What does that indicate to you? What operation? Second? Quotient means division. Difference means subtraction. You're going to be subtracting and dividing. We've done that before, haven't we? Okay? What do we mean by difference quotient? One of the basic definitions that you'll be using in calculus, I hope several of you will continue to do calculus, employs a ratio that is, someone remind me, what does F stand for? F of X is always Y. Yes, remember that. Remember that. So this is Y here at one point X. This is Y a little bit further away. H is some small number, greater than 0, not equal to 0, some number a little bit away. So this is really a Y2 minus Y1, isn't it? One Y and another Y. And guess what? That's just an H down here. Where do we get that? X plus H minus X. This is your first X. There's your second X. X2 minus X1 was X plus H minus X. X plus H minus X. H. That's your difference in X. This is a change of Y or a change of X. What's that represent? Y2 minus Y1 over X2 minus X1. Slope. That is a slope. Yes, you've done this before. You just didn't call it a difference quotient. There's your difference. That's really a difference too. And here's your quotient. There's your difference quotient. That ratio, which is a division, is called the difference quotient. Okay? And here's example 11. Here's a function, f of x equal x squared minus 4x plus 7. It says find that difference quotient. Well, what are we going to have to do first? What's the first term in that difference quotient? Read it to me. What is it? F of x plus h. That's the first thing we've got to do. Now we know what f of x is. How do we get f of x plus h? Second? Okay. They told us what f of x was. How do we calculate what f of x is? Got to figure out that before you can take a difference quotient, don't you? What is your f of x plus h? How do we get that? We did it maybe last week. I know it was a long time ago. What do we do? Okay. What was here? Your x. And there were your x's. So now instead of x, we're putting x plus h. So what do we do over here? everywhere you see an x, you put an x plus h. So the first one will be x plus h squared minus 4 times x plus h plus 7. There it is. Now you just got to do a little math, but that's the fun part, right? What's x plus h squared? Anyone know? Say again? A little louder. Help me. H squared? Okay, I can't hear it. X h squared.
That's what I see.
Okay. What do you do with your plus sign? You just threw it away, huh? It's just a little sign, yeah. You can't do that. What does it mean, x plus h squared? What does it mean to square something? Say again?
Multiply
By itself, exactly. So that would be x plus h times x plus h. Okay? And what would that be? How do you do multiplication of binomials? Curses, foiled again, okay? First is x squared. Outer is plus xh. Inner is another plus xh. And last is plus h squared. Any like terms? Yeah, 2 of those. So you have x squared plus 2. And you can say hx or xh, I don't care which. xh plus h squared. That's what it is. And so you're happy. It's a smiley face. Okay. So this becomes x squared plus 2xh plus h squared. A little time out here. Now, you can always do this. You can always do whatever you're trying to square, multiply it by itself. You can always do that. But if you're good and lazy, and I have told you what I think about good mathematicians, right? You need to be a little bit lazy, okay? And always trying to find an easier way to do the problem, okay? So you can do that, multiply it out, is fine. A little bit of work, but not too bad. Or you can do this. Square the first term, x squared, plus twice the product of the 2 terms. The product would be your xh. Double that, plus 2xh, square the last term. Works in. Does that have been a minus in there? Only difference, square the first. Twice the product, that would have been a minus 2xh plus h squared. So there, if you want to be a little lazy, there's an easy way to do it. But if you forget that, you can always go back and do that. All right, continue. What's next? A little louder. Negative 4x. A little louder. I can't hear. Minus 4h plus 7. There's your alpha of x plus h. Okay? And what are we going to subtract from that? Alpha of x. Do we know what alpha of x is? Sure we do. It's right there. Yeah, there it is. So it's going to be minus, I'm going to put it in parentheses, x squared minus 4x plus 7. Okay? I'm going to erase my little chicken scratch over here if that's okay. That was just to see if you see what x plus h squared was. So it won't be confusing the problem. Okay? Now, all that divided by h. So let's take that numerator. Unfortunately, there's no like terms in the first part. Just write them down. X squared plus 2xh plus h squared minus 4x minus 4h plus 7. Now, that minus in front of parentheses does what? It what? Changes the signs of everything inside, so that becomes minus x squared plus 4x minus 7. Yeah, you distribute the minus 1 across all three terms inside the parentheses. Okay? And that thing all is over h. Okay? Now, do we have any like terms that we can deal with? X squared. There's an x squared here. Minus x squared, that adds a 0. I'll just get rid of that one. Okay, there's a negative. Let's just write down what's left. 2xh, that's the only thing we've got there. Plus h squared, that's the only thing we've got there. Here we have a minus 4x and a plus 4x. Those add to 0. Ha! I'm liking this more all the time. Okay, then we have a minus 4h. I used to be in that. Okay, and then plus 7 minus 7, those go away. Hey, that got a lot simpler, didn't it? Divided by h. Now, what do you notice here? Oh, all those in the numerator have an h, so what do we do with it? What's the F word, folks? Factor. Let's factor out that h. And what do we have left? 2x plus h minus 4. You see? And that's divided by h. And guess what we can do now? Yeah. What's h over h? Say again? What's h over h? 1. So divide that out. There's our difference quotient. 2x plus h minus 4. Now, are any of you going to continue and go to calculus at some point in your lifetime? Yes, good. One of the calculus has two main parts. Some people call it a third, but there's differentiation and integration. When you differentiate, you take the limit of this difference quotient as h goes to 0. You know h can't equal 0, but when you got out of it here, now you can let this h get as small as you want to, and what you're left with? 2x minus 4. And later you'll see when you take the derivative of that function, it will be 2x minus 4. That's what a difference quotient is used for. Okay? But it's also a slope. And a derivative gives you the slope of a tangent line. As the difference between x plus h and x gets smaller and smaller and smaller, it's a secant line coming down to a tangent line, slope of a tangent line. That's exactly what we did. Use the slope formula to get that. Okay? And there they have 2x plus h minus 4. And they always say h cannot equal 0, but it can get very close to it. Okay. Good deal. There is a checkpoint there. I highly recommend you do the checkpoint. Okay. Now, let's clear all my scratch out of the way. Any questions before I clear it? Okay. Now let's see how they do it. First thing they do, well, they write it all out, and then they put f of x plus h inside these brackets, minus f of x inside that one. I recognize that. That's right there. F of x plus h, though, you have to put x plus h squared minus 4 times x plus h plus 7. So yeah, they did the same thing we did. They just write it a little differently. All divided by h. Okay? Now, they don't show you all the steps, but here's what you get. I'll tell you most of them. This thing becomes x squared plus 2xh plus h squared minus 4x minus 4h plus 7 minus x squared plus 4x minus 7. All over h. Okay? Just like we saw before, the x squareds go out, the 4x's go out, and the 7's go out. They've been negative. Okay. So you wind up with 2xh plus h squared minus 4h, all divided by h. And then, as you noted, there's an h in every term. So factor it out of the numerator and leave you 2x plus h minus 4 in the numerator. Divide out the h's, and you're left with the difference quotient is 2x plus h minus 4. Again, h can't be 0, but it can get as close to it as you want it to, the limit. Okay? Any questions? All right. Now here's a summary of your function terminology. First, what is a function? Relationship between two variables, such that for every independent variable, that's the one usually on the right, okay, not always, every value of the independent variable, there's one and only one value of the dependent variable. That's the thing on the left. The y is the dependent, x is independent. Now, this is the main thing to remember in this course. Y is equal to f of x. If you can remember that, you get most of your problems solved right there. Okay? So f is the name of the function, like Fred or whatever. Y is the dependent variable. X is the independent variable. Reason for that? You choose the x, y depends on x. Okay? You choose the x, any x, that's what makes it independent. F of x is the value of the function x, or in other words, the y value. The domain of function is a set of all the input variables. Okay? All those input, all the variable values that can take on. If x is in the domain of f, then x is said to be defined at f is said to be defined at x. If x is not in the domain, then f is undefined there. Like those we did with the alternate fuels. Year 2000 made no sense because it wasn't in the domain of that function. Year 2020 wouldn't make any sense. It's not in the domain. The domain was between 2008 and 2015. Piecewise defined, this was the first 4 years, that's the last 4 years. That's the only place those were defined. Okay. The range is a value, the set of all values of your outputs or your dependent variable, set of all the function values. Implied domain, if f is defined by an algebraic expression. Now the one we did alternative fuels, that was a explicitly defined domain. 2008, 2009, 2010, yeah, you got it. Implied domain, that would be something about the problem. Either a variable in the denominator that can't be, the denominator can't be 0, variable under a square root that can't be, the expression under there can't be negative, and later we'll do logs, okay? Those are your implied domains, okay? Or implied physically. Balls can't have negative radii. Balls can't have negative volume, those kinds of things. You can't have a negative number of filling stations, okay? That would be the type of thing, okay? So those are your summary of function notation. Any questions on 1.4? Okay? Let's quickly do vocabulary. A relation that assigns to each element in X, from a set of inputs, or what's that set of inputs called? A little louder? Domain, excellent. Exactly one y, element y, in a set of outputs, or what's the set of outputs called? Set of outputs? Range. A relation that assigns to any input one and only one output, that's called a blank. Function, excellent. Number 2. For an equation that represents y as a function of x, the set of all values taken on by the blank variable x. What do we call the blank variable? The x variable. Independent variable is in the domain, and the set of all values taken on by the blank variable y, dependent variable y. Number 3. If the domain of the function f is not given, then the set of values of the independent variable for which the expression is defined is the blank blank. If it's not given, if it's not explicit, it's implied domain. Okay, if we weren't running out of time, I'd let you sweat. Okay, never mind. One of the basic definitions of calculus uses this form: f of x plus h minus f of x over h. As long as h is not 0, this ratio is called a difference quotient. You got it. Homework exercises, do either 5 or 7. Both of those are on calcchat.com, 7's on calcview.com. And that little square barcode type looking thing, that you can do it with your reader and you can get that up, pull it up immediately. Do number 9, it has 4 parts. Do any of the odds 11 through 17, all those are in calcchat.com, 11's in calcview.com. Do any of the odds 19 to 29, they're all in calcchat.com, 21's in calcview.com. Do either 31 or 33 or both, those are piecewise defined functions. Do any of the odds 35 to 41, all those are on calcchat, 37's at calcview. Do either 43 or 45 or both are at calcchat, 43's at calcview. Do either 47 or 49, both of them at calcchat, 49's at calcview. I'm sorry, that's 47 through 55. All of them are at calcchat, 49's at calcview. Then do any of the odds 57 through 71. Okay? They're all at calcchat.com. Then do any of the odds 73 through 79. They're all at calcchat, 75's at calcview. Do either 81 or 83. And the rest of those you can look at, read through, and follow up on. And we are through with 1.4. We'll move on to 1.5. Okay. Remember, anyone who came in late, there is no class on Thursday. I've got an infusion Thursday. We're going to make up that class next Tuesday at 12:30. We'll have an 8 o'clock class on Tuesday, then a 12:30 class on Tuesday. I'll record them on YouTube. Yes, ma'am.
I have my paper.
Okay, fantastic.
And I tried to do it in the library, but they said they have a card. And I couldn't print it off.
Right.
Can I email it to you?
You can't, but I have to grade what I receive. So you print it off in the library, you look at it, oh, I didn't want it to look like that. Well, if it looks like that, I'll grade what I get. So it's up to you. I'll take them most of the time, they come out fine.
Okay, so the best thing is to email it to you.
That you can do that.
Okay.
You certainly can.
And how frequently do you check your emails?
I should be checking this afternoon. I've got class all morning, but then in the afternoon I got it.
Okay. So I'll go to the library now and
Okay.
just forward it
That'll
to
be
you.
fine.
Okay, thank you.
Thank you.